Hey YouTube, welcome back. Today we continue our series in design a YouTube. We have a system design question, which is design a YouTube. In the previous video, we talked about the CDN and the blob storage, and in this video we will talk mainly about the uploading flow. Yeah, so let's just start into it. So let me just create title. It will be uploading flow. I want to make it quite big. Yeah, AET, and yeah. Okay, so we will start first as the user, our own lovely user. We have it here. So, it's big gone. So our user, that could be mobile or web browser or TV. TV, smart TV. So let me just start to make this. Yeah. Okay. And let's just see right now. There is two flows that we will talk about. We will talk about the general flow of the streaming and getting the static content. And in the next videos, we'll talk on each one of these flows on its own in more depth and more details. So let's start first. We have the client will connect with a load balancer. So the purpose that the client will connect with a load balancer is to distribute the incoming request across multiple servers. So on high level, load balancers are essential components in modern network and web architecture. They distribute incoming network traffic or application requests across multiple servers, ensuring that no single server is overwhelmed with too much traffic, thus optimizing the use of resources and improving system performance, scalability, and reliability. So right now we have this load balancer to route the incoming requests, and right now the load balancer will connect with API servers. And if you don't know, API servers are the concept of API servers, also known as application programming interface servers. They are software components or services that provide a set of rules, protocols, and tools for building and interacting with APIs, which is application program interfaces. APIs allow different software applications to communicate and interact with each other, enabling the exchange of data and functionality. Okay, so API servers are responsible for managing and serving these APIs to clients. And the APIs will connect with two things. With the, let me just have this one because I guess I need it. With a metadata database, because we'll take the data metadata, like for example the title, the likes, the comments, these type of data, the metadata database DB, and also it will connect with the cache, the metadata cache. It will connect with the cache metadata. I guess I should put metadata which with each other, no need to make a space, but yeah. Yeah, let's make it like that. I guess this is why this way is. Okay. So right now we have the API servers connected with the metadata and metadata cache, and the metadata cache is connecting with something called a completion handler. The completion handler is this consists of a list of workers that pull event data from the completion queue, and I will talk what it is a completion handler and completion queue in a bit. But like, let's just start right now to talk about this way the user is taking the metadata that it needs. However, how the user will connect with the CDN. So a good way to see how it's connected with the CDN, let's create one right now here. So this will be the original storage, which will be كده blob storage or something like that. Original storage. This is where we store all of our videos. Okay, and the original storage is connecting with the CDN, and the CDN is directly it's if you didn't watch the previous video, the CDN is a content delivery network. Is a network of a network of distributed servers, and these are strategically located in data centers around the world. The primary purpose of CDN is to deliver web content such as images, videos, scripts, style sheets, and other assets to user quickly and efficiently. So the CDNs achieve this by catching the serving content from the server that physically closest to the user. So the CDN will catch the data and store it to the server, the server that is closest to this user. However, we need to have a connection between the metadata and the actual video. So how can we establish that? So let's just push the CDN down, and we will start to introduce something different. We will start to introduce something called transcoding servers. Transcoding servers. And these transcoding servers, the transcoding servers, these are like video transcoding, is also called video encoding. It is a process of converting a video format to other formats. Like, for example, we have HLS, MPG, which provide the best video streams possible for different devices. And we talk about what that in details. So first of all, if you just give it a go, the transcoding servers, they are connecting directly with the CDN because they are providing a different format. So in conclusion, the transcoding format servers are specialized servers or software components responsible for the process of transcoding multimedia files. Transcoding involves converting multimedia files from one format or codec to another. This conversion could include changes in the file format, resolutions, brightening, or even the codec used to compress the audio or the video. So we have here the something called a transcoding storage. Transcoding storage, and in this one a transcoding storage, it's a blob storage that stores transcoded video files. Okay, there is no need to make this seek bigger. And we have the transcoding storage is connecting with the CDN, and we have the transcoding is working with something called completion queue. Completion queue. Completion queue. Completion queue. Okay, and this is a SAQS queue, and the completion queue is working with something called completion handler. We talked about this later. We talked about previously. So the completion queue is a message queue that stores information about videos transcoding completion events, and handler. Okay, and completion handler. This is consists of a list of workers that pull event data from the completion queue and update metadata cache and database. And right now we have this one, and this one is pulling from the database. So it's pulling from the cache and also pulling from the database. Okay, so let's just try to make a quick review on this. Can I make this like that? So it will be in one. Yeah, and just bring it. Yeah. Okay, that sounds good. Okay, so let's just try to make it easier. So for example, we have the user, and the user watches YouTube on devices such as mobile, web, or smart TV. We have the load balancer. The load balancer evenly distributes requests among API servers. We have the API servers, and the API servers, all user requests go through API servers except videos streaming. Okay, because the video streaming go on this flow. We have the metadata DB, and the metadata DB video metadata are stored in the metadata DB. It is sharded and replicated to meet performance and high availability requirements. So let's just say what is sharded and what is replication. So sharding is database design and management technique used to improve the scalability and the performance of large-scale database system. It involves horizontal partition data across multiple physically or logical databases called shards. Each shard contains a subset of data set, and collectively they make up the entire database. Sharding is commonly employed in situations where a single monolith database become a bottleneck due to its size and the volume of incoming database requests. So if you don't understand what I'm talking about, let's assume that we have a database here, and this database have too much data. So what we do, we just do sharding. So instead of have database, we just shard, and we have a lot of data, and these data just start to be quite big for this database. So what we do, we create sharding. So sharding, instead of have one data, we just shard the data into different 3 databases. Okay. By this way, we don't have any bottleneck, so each one will have its own data. So this good way to be always available and and have a scalability and meet the scalability requirements. And also there is something else that we talk about, the replication. So replication. So in replication, it's the second step that we do to improve the performance of the database. So will be, I guess there's a problem with me because I can't click on it. Give me a minute. Okay. Okay, so again, sorry, I'm coming back. It was an error. Okay, so database replication is a process in which data from one database known as the source or the master database is copied to another more it's copied to one or more other databases known as replicas databases. The purpose of database replication is to provide redundancy, improve availability, and distribute data across multiple locations or servers to enhance performance and disaster recovery capabilities. So we have these three sharded databases. We create a replicas for them. So each one we can create 2 replicas, and we just copy all the data that they have here. And also, like, a quick tip, that these two databases here that you can see right now, they can serve the read requests and only the master, because it will be a master slave. So these 2 slaves are copying everything the master has. So the master will support the write operations, and the slaves will support the read operation. And when the master go down, we have one of the slaves will be the new master, and the other slave will just and in this master will serve the read the write operation, and the slave will just acknowledge that and just try to copy everything from the master. So this is what sharding and replication means. And we have the metadata cache. Let me just go back here. We have here the metadata cache, and the metadata cache for better performance, video metadata and user objects are cached, the frequently accessed one. We have the original storage here. The original storage is a plop storage system, is used to store original videos, and a plop storage is a collection of binary data sorted in a single entity in databases management system. We have the transcoding servers, and the transcoding servers, the video transcoding is also called video encoding. It is the process of converting video format to other formats, which provide the best video streams possible for different devices and bandwidth capabilities. We have the video transcoded storage, and it is a plop storage also that stores the transcoded video files. We have the actual CDN, and these videos are cached in CDN. When you click the play button, a video is streamed from the CDN. We have the completion queue, and the completion queue is it is the message queue that stores information about video transcoding completion events. And we have here the completion handler, and this consists of a list of workers that pull event data from the completion queue and update metadata cache and database. So now that's it. I guess it's I don't know how long this video is, but I guess it will be more than 10 minutes. Let me just, I guess now we finished with the uploading flow, and in the coming videos, I guess we will talk more in depth on one of these 2 flows, because if you can see here, we have 2 specific flows. One is the upload the videos flow, and we have the upload the video flow, and we have another one is to update the metadata. So first we talk about the uploading flow, the full uploading flow. In the next videos we will talk about the upload the video flow, and the other after that we'll talk about the upload metadata flow. So that's it for this video. I hope my description was quite good. If you like my content, make sure to subscribe and hit the notification bell so you'll never miss a video. And yeah, so it was good to talking with you. Or like, I don't know if I didn't talk with you because like talking means that you talk, I'll talk you back, like just whatever, let's not talk about that much. So it was nice to talk with you, and I hope that I can see you in the future videos. So bye bye.